Hi everybody, today's lesson is going to be 7.1 and this is our first lesson on triangles. For today's lesson you're going to need your textbook. We'll start on page 313. You're also going to need some pencils and highlighters and then possibly a calculator. Everything that we do today can be done without a calculator, but I know that you guys like to have one. So pause the video, go gather up your supplies and come back. Now that you're back and you have your textbook and we're on page 313, we're going to start by talking about interior and exterior angles. Interior, as we learned with parallel lines and transversals, means inside and exterior means outside, but you probably already knew that. And the first thing that they start with is this little example where it shows that if you were to take a triangle and you were to tear off all of the corners, you could lay them in a line. And as we know, a linear set of angles is going to total 180 degrees. So down here toward the bottom of the page, grab your highlighter and we need to mark the triangle sum theorem, which just very simply says that the sum of the angle measures of a triangle is 180 degrees. That's a really simple fact. As I've said a lot already this year, a lot of geometry calculations are just knowing what things are equal to each other and when you add things up to equal a third number. And this is one of those cases that you're going to add things up and equal a third number. To go an additional step further and prove that this is in fact what's happening, we have a proof down here at the bottom. It says fill in the blanks to complete the proof of the triangle sum theorem. Given triangle ABC, which is here, ABC, prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And as you can see, 1 and 2 and 3 are all inside the triangle. They're interior angles. And so therefore we're proving the triangle sum theorem, which is that these three angles should total 180 degrees. So step 1 or statement 1 was to draw a line L through point B and parallel to AC. You can do this because there's only one line that's going to be parallel to AC, which also passes through B. And that's what the parallel postulate says. So once we have that line drawn, the measure of angle 1 equals the measure of some other angle. Well, if these two lines are parallel, AB over here is basically a transversal between this bottom line of our triangle and line L. So angle 1 is going to be congruent to angle 4. The measure of angle 1 therefore equals the measure of angle 4. Also, the measure of angle 3, to get a different color, is going to be equal to the measure of angle 5. Right? We have another transversal that goes through this bottom line of the triangle and line L. And so angles 3 and 5 are alternate interior angles, just like angles 1 and 4. So that is the alternate interior angles theorem. Lots of abbreviations to get that to fit inside the blank. Next, they have the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 all add up to 180. 4 and 2 and 5 are all up here along this line. And just like we had a little higher up on the page, a linear set of angles is going to add up to 180 degrees. So of course they all add up to 180 degrees because this is the angle addition postulate and the definition of a straight angle. The straight angle, of course, being line L. So now we're going to use some substitution and we're going to replace some of these numbers because we're trying to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And once again, we were able to do that by substitution. If you're wondering where the substitution happened, we swapped out angle 4 for angle 1 because up here angles 1 and 4 were equal. Then we separately swapped out angle 3 where angle 5 used to be because angles 3 and 5 were equal up here in line 2. So that's substitution. All right, so I'm actually going to go ahead and we're going to do just a little bit of answering over here, and then we're going to go to problems in the back of the chapter because I want us to do some practice with this before we start our next concept. So number 2, what does the triangle sum theorem indicate about the angles of a triangle that has 3 angles of equal measure? Well, if the triangle sum theorem basically says that one triangle has 180 degrees in all of its inside angles, and then we have 3 angles of equal measure, We can take that 180 degrees and divide it by 3. You can do that in your calculator, or hopefully you can do that in your head. All 3 of the angles would be 60 degrees. So that's what we're going to write. All 3 angles equal 60 degrees because 180 divided by 3 equals 60. This is also called an equilateral, an equiangular triangle. And just to be really clear, equilateral and equiangular triangles are going to be the same. If all the angles are the same side, all of the sizes of the lines are going to be the same as well. And that's a concept that we'll talk about a little bit later. So let's do a little bit of practice with this. Go ahead and flip over to number 21 on page 323. All right, so you can see we have 2 triangles. You guys know I like to highlight the color code and to kind of simplify all of the work that our brain is doing. So I'm going to color code one triangle like this. And we can see that the 3 corners of that triangle are 55 and 80 and Y. Well, we know that in one triangle there should be a total of 180 degrees. So 55 degrees plus 80 degrees plus Y degrees should equal 180 based on the triangle sum theorem. Naturally, you would know how to solve this. You can just take 180 and you're going to subtract the 55 and the 80. It does not matter to me if you want to subtract them one by one or if you want to add them up first and say that this is 135. It's going to come out the same either way. So then we're going to subtract 135 from both sides. And we have, oops, I did that backwards. 45 degrees. There we go. So that's half of our problem worked. Now on the other half, we have X and 160. Okay, angle X, angle 60, this angle that's 100. So you can probably look at that and know that X is going to have to be 20 degrees. But just to practice setting up the equation, right? We want to practice setting up the equations when they're easy so that we're not struggling to know what to do when they're harder. So 100 plus 60 plus X is going to equal 180. So 160 plus X. Subtract that 160 from both sides, and X is of course 20. So we do actually have a third triangle. It's down here in the middle. And so what I'm going to do is I'm just going to draw this a little bit larger outside the regular diagram so that I can put those numbers in there. So if Y was 45 and if X was 20, we need to know what Z is. So once again, we'll set up an equation. 20 plus 45 plus Z equals 180 degrees. So you can combine like terms if you would like. I'm just doing that to be consistent. And then you're going to subtract once again, like we have been. And so you would have 115 degrees for angle Z. So not too bad. The triangle sum theorem, again, just says that in every triangle, whether that's our pink triangle or whether that's our green triangle or whether that's our blue triangle or some other one entirely, every triangle will have 180 degrees as the sum of the interior angles.